Hello, my outstanding pre-calculus class. We are ready for another online adventure. Today we will solve trigonometric equations using our fundamental identities. If possible, we want to obtain an equivalent equation that has only one trigonometric function in it. And we're going to be using our fundamental identities found on pages 634 through 636 in our ebook. And they look like this. You see, we have our Pythagorean identities, even odd identities, reciprocal identities. You see our sum and difference for cosine and sine, cofunction identities, double angle identities, reduction formulas, our half angle formulas, our product to sum and sum to product. Well, these are the fundamental identities that we have been talking about. And again, they're on pages 634 through 636 in our ebook. We are going to find all exact solutions on the interval from 0 radians to 2 pi radians using our fundamental identities. Let's first of all look at this equation. 2 times cosine squared of x plus 3 sine of x equals 0. See, we have two trig functions. We would like to have only one trig function. According to the Pythagorean identity, sine squared of theta plus cosine squared of theta equals 1. And if we solve this for cosine squared of theta, we get 1 minus sine squared of theta. Now this theta is like a dummy variable here. We can use any letter that we like. So we could have substituted for theta the x. So we're going to substitute for cosine squared of x. We're going to substitute 1 minus sine squared of x. Use our distributive property, 2 times 1, 2. 2 times a negative sine squared of x is a negative 2 sine squared of x. Bring down our 3 sine of x equals 0. We're going to put our terms in descending order according to the exponent of the sine function. And notice this is negative, and we usually like for that first term to be positive. So what we're going to do, we're going to multiply both sides by a negative 1. And we end up with 2 sine squared of x minus 3 sine of x minus 2 equals 0. Now we're going to let u be equal to the sine of x and do the substitution here so that it'll look more like a trinomial that we're used to factoring. And then we're going to factor this trinomial into two binomials here. And remember, whenever you factor, always go back and check it using our FOIL, first, outer, inner, last, to make sure we're getting this trinomial. Next, we're going to set each factor containing a variable, set it equal to 0. So we're going to set 2u plus 1 equal to 0. Then 2u equals negative 1, and u is equal to a negative 1/2. We're going to substitute for sine of x for u. So here's u, substitute sine of x is equal to a negative 1/2. So x equals inverse sine of a negative 1/2. And sine is negative in the third and fourth quadrants. So if we go to the third quadrant, we want a sine that is a negative 1/2. And sine, remember, is what, the y-coordinate? So it's right here, see 7 pi over 6. And over here in the fourth quadrant, where the sine is a negative 1/2, it's what, 11 pi over 6. So we have here that the sine is negative in these two quadrants. So we have one solution to be 7 pi over 6 for x, and the other angle to be 11 pi over 6. But remember, we also had this equation, u equals 2. We substitute for u the sine of x. So x equals the inverse sine of, and I should have put a 2 here. So let's put a 2 here now. Then when we put this into our graphing calculator, we get an error because remember the domain for inverse sine is from negative 1 to 1 inclusive. So our answer for this particular equation will be x equals 7 pi over 6 and 11 pi over 6. Let's look at a second example. Cosine of 2x plus 3 sine of 2x minus 2 equals 0. Again, notice that we have two trig functions here. So this is a double angle. And one of the definitions for the double angle for cosine of 2x is 1 minus 2 sine squared of x. And I chose that one because you see this is what, in terms of what sine of x. And I do my substitution for cosine of 2x, which will be 1 minus 2 sine squared of x. Bring down the plus 3 sine of x, bring down the minus 2 equals 0. Then I put the terms in descending order according to the exponent of the sine. Negative 2 sine squared of x plus 3 sine of x. And a positive 1 plus a negative 2 gives us a negative 1. And again, this first term is negative, so let's make it positive by multiplying both sides by what? A negative 1. So we get 2 sine squared of x minus 3 sine of x plus 1 equals 0. And we're going to let u equal sine of x so that the trinomial, again, will look more like what we're used to factoring. So we're going to factor this trinomial, this on the left, and we're getting the quantity 2u minus 1 times the quantity u minus 1 equals 0. We're now going to set each factor containing a variable, set it equal to 0. 2u equals 1, u equals a half. So sine of x is equal to half. And over here, u minus 1 is equal to 0. U equals 1, so sine of x is equal to 1. Now, this says that x equals inverse sine of a half. And sine is positive in the first and the second quadrants. So let's look. First quadrant, the sine is a positive 1/2. You see, that's the y-coordinate on the unit circle, pi over 6. In the second quadrant, you see sine is a half, which is what? 5 pi over 6. So that's how we're getting x equals what? Pi over 6, and x equals 5 pi over 6. Now we're looking for an angle whose sine is 1. So we go back to our unit circle, sine is 1. You see right here, the y-coordinate is 1, so the sine of pi over 2, which is the same thing as what, 90 degrees, is equal to 1. So we have our three answers here, our three solutions. Pi over 6, pi over 2, and 5 pi over 6. Let's look at a third example. Here I have cosine of x times cosine of 2x plus sine of x times sine of 2x is equal to the square root of 3 over 2. Well, this is going to be a cosine difference. If you look there on page 635, we're looking for a cosine difference. See cosine difference right here? It's a cosine of alpha times a cosine of beta plus a sine of alpha times a sine of beta, and it's equal to cosine of alpha minus beta. So alpha is x and beta is 2x. So we have cosine of alpha minus beta. Again, the alpha is x, the beta is 2x. When we subtract, we get cosine of a negative x. But remember that cosine is an even function. So cosine of a negative x is the same thing as cosine of x, which is equal to square root of 3 over 2. We're looking for the angle whose cosine is square root of 3 over 2. X equals inverse cosine of square root of 3 over 2. We're looking for the angle whose cosine is square root of 3 over 2. Well, cosine is positive in the first and the fourth quadrant. So let's look in the first quadrant. And we're going to have a cosine, you see right here. That's what? Square root of 3 over 2, pi over 6. In the fourth quadrant, square root of 3 over 2, 11 pi over 6. So our solutions here will be x is equal to pi over 6 and x is equal to 11 pi over 6. Now this is a video, and remember whenever you're viewing this video to stop, rewind, review. Stop, rewind, review. My love goes out to you.